So let's start by just recalling the things that we got last time. So we did a little bit of geometry and thought about what this geometry meant for trig functions, and got some results. So if you take an angle and you rotate by that angle, and then you rotate by an extra 2 pi radians, you don't change the xy coordinates where you land, do you? So all of the trig functions should be unchanged. And as a consequence, you see that cosine and sine, and as a consequence, all of the trig functions remain unchanged when you change their argument by an extra 2 pi. If you replace an angle by either 2 pi minus that angle, or just by minus that angle, that amounts to taking the point in the xy plane where you land after rotation and reflecting over the x-axis. So the x-coordinate cosine should stay unchanged. The sine coordinate should become negative. If you take an angle and replace it by pi minus that same angle, you reflect over the y-axis. And so the cosine, the x-coordinate, should become negative. The y-coordinate should remain the same. And it'll be a really similar couple of symmetries that we'll use to get the remaining identities. So let's start talking through them. So all of these arguments will be really similar, well, except maybe for the last one. So here is an angle theta, and that same angle theta, but with pi added to it. Maybe I'll motivate it this way. What sort of angle does pi radians correspond to? Pi radians is how much of a full revolution? It's half of a full revolution. So that should be like taking every point in the xy plane to the exact negative of that point. Another way of saying that is reflection across the origin. And as a consequence, reflection over the origin, what does that do to xy coordinates?
Invert both of them. Not invert, just negative them.
Negates both of them. I guess it additively inverts them. So that means that the x-coordinate should go to exactly negative the x-coordinate. So as a consequence, the cosine of pi plus theta, how should it compare with that x-coordinate? Should be exactly negative what it used to be. So the cosine of pi plus theta is exactly negative the cosine of theta. Similarly, oops, that should be red. Green. This y-coordinate should be exactly the negative of that y-coordinate. So the sine of pi plus theta should be exactly the negative of the sine of pi plus theta. So the cosine of pi plus theta is negative cosine theta. Sine of pi plus theta is the same as negative the sine of theta. And that gives us our next line in the table on the front page. Is the lime green totally invisible, or is it okay? Should I avoid it? Okay. I will not use it again. So y becomes negative y. So the new y-coordinate, sine of pi plus theta, should be exactly the negative of the old y-coordinate. Cosine of pi plus theta is negative cosine theta. Sine of pi plus theta is negative the sine of theta. And so that gives us some of the entries we wanted on that front page. I note, so the cosine of pi plus theta is exactly negative cosine theta. Sine of pi plus theta is exactly negative the sine of theta. And this is true because this amounts to a reflection over the origin. I'm still going to feel so far. That seems okay? Totally believable? Do you think we can get corresponding identities for all the other trig functions out of this? Yeah. Presumably we can. And maybe I'll follow the same model where I'll talk through one of them, and then I'll have you guys do the remainder in some sort of groups. So I'll do one of them, and I'll let you guys pick. How many people would like me to talk through secant? Cosecant. Tangent. 2 hands. Cotangent. 3 hands. 4 hands. I'll do cotangent. So let's try to think through what the cotangent of pi plus theta should be. And we'll follow the same plan as we did last time. What's cotangent in terms of sine and cosine? Cotangent is cosine over sine. So cosine of pi plus theta should be the same thing as the cosine of pi plus theta divided by the sine of pi plus theta. What's the cosine of pi plus theta the same as? Negative cosine theta. And the sine of pi plus theta is the same as negative sine theta. So, on the one hand, there's an answer, negative cosine theta divided by negative sine theta. Let's think about any simplification. Does anything cancel in that? The negative signs cancel. So you wind up with just cosine divided by sine. And what is cosine divided by sine? Cotangent. So cotangent doesn't change when you add a total of theta to that angle. And the only difference between cotangent and tangent is, well, they're like reciprocals of each other, right? So what do you think should be true about tangent of pi plus theta? Should be the same as tangent theta, probably? And maybe we'll even check that really quickly. So remember, tangent is supposed to be like the slope of a line. So if you look at those two line segments, right, remember slope is delta y over delta x. How do those slopes compare? The same? Right, those are actually parts of the same line, aren't they? So yeah, those should be the same, and indeed they are. So I would like you guys to take a moment and do the same thing, but for secant or cosecant. How many people would themselves rather do secant? How many people would rather do cosecant? Okay, you're the only one I talked about, so this side will be doing cosecant. This side will be doing secant. observing and seem to be getting favorable. What's the secant of pi plus theta? Negative secant. What about the cosecant? Nice. How do people feel about that? Anyone want me to talk through one of those two? Okay, awesome. That's right, it's the same idea as we've done a few times last time. Once you get an identity for sine and cosine, you know all of the trig functions in terms of sine and cosine, so you should be able to get some new facts. So I think instead of, well, maybe I'll see. How many people would like to go through a computation using those facts? Okay, let's go through a computation using those facts. So recall from last time, we didn't justify why these numbers are what I'm going to say there, but we stated what they are. What's the cosine of pi over 8?
Square root of 2 plus square root of 2 over 2.
Yeah. With parentheses aligned appropriately.
Yeah.
And what's the sine of pi over 8?
Same thing except minus the square root of 2.
So let's see if we can't use that to get some stuff. So tell me, as a consequence, let's do like 2 and 3. Maybe those are 2 good choices. So let's try to compute the sine of 7 pi over 8. And the way of thinking about that is, well, 7 pi over 8, the closest multiple of pi from that is pi. And you're only short by pi over 8. So sine 7 pi over 8 is the same thing as pi minus pi over 8. By the identities we've just established, what is the sine of 7 pi over 8? Let's see, what is the sine of pi minus an angle? Yeah, say that one. It's the same as sine of just that angle. So the sine of 7 pi over 8 should be the same thing as just sine of pi over 8, which we already know. Cool. And you can do the same thing for 9 pi over 8. You take a glance at 9 pi over 8, the closest multiple of pi is pi. And you've overshot by pi over 8. So 9 pi over 8 is the same thing as pi plus pi over 8. And what is the cosine of pi plus pi over 8 the same as? What's the cosine of pi plus any angle? Negative cosine of that same angle. So this should be the same thing as negative cosine of pi over 8 by those identities which are on the false page. And what is negative the cosine of pi over 8? Well, it's negative that thing that we wrote down. Negative the square root of 2 plus the square root of 2 all over 2. And maybe we'll go ahead and do a quick sanity check, just see if these have the right positivity or negativity. 9 pi over 8, what quadrant does that live in? 3. Quadrant 3, right, so there's 9 pi over 8. So should that cosine be positive or negative? Negative? And indeed it is. 7 pi over 8, what quadrant does that live in? Let's see my poll. How many people say quadrant 1? Good. How many people say quadrant 2? 7 pi over 8.
Yeah, that's quadrant 2.
How many people say quadrant 3? Quadrant 4? Good, right? Because 7 pi over 8 is you go forward by pi, putting you at -1, 0, and then you rotate back by a little bit, putting you in quadrant 1, I guess? Nope, quadrant 2. So this is in quadrant 2, so should sign be positive or negative? In quadrant 2 is the y value is positive, so it should be positive. And yeah, that's positive. So yeah, that seems to hold on. Okay, let's keep on going. The next one on the list, let's make sure that I actually wrote this one down, is what happens when instead of thinking about pi plus or minus, what happens if you think about pi over 2 plus or minus an angle? And let's start with minus. So here's a picture of rotation by some angle theta. And here's rotation by pi over 2 minus that angle theta. And let's think of that picture this way. So that means that you could get to this point by rotating forward by an angle of pi over 2, a right angle, and then backwards by theta. So that means this angle is also theta. And just by looking at those pictures, what symmetry of the plane seems to relate them? So there's, just like before, we want to use some symmetry of the plane to go from this point to that point. What symmetry appears to do the job?
The line y equals x.
Yeah. More precisely, reflection over that line. Yeah. So reflection over the line y equals x. And reflection over the line y equals x, what does that do to xy coordinates? Flips them? So that means that the x coordinate becomes the y coordinate, and the y coordinate becomes the x coordinate. So using that, this x coordinate should be the same as that y coordinate. So the cosine of theta should be the same thing as the sine of pi over 2 minus theta. Similarly, the sine of theta should be the same thing as the cosine of pi over 2 minus theta. And that gives us two more identities. Cosine of pi over 2 minus theta is the same as sine theta. Sine of pi over 2 minus theta is the same thing as the cosine of theta. Putting those back on that front page so that we have all of the identities written in the same place somewhere. And maybe we'll even put down the reason that that happened. Why was this? This was because of reflection over the line y equals x. And just as before, let's go through all the motions. Let's figure out the other trig functions. And maybe here's how I'll do things. I'll talk through secant, then I'll just write down the result for cosecant, and then I'll have you guys do tangent or cotangent, depending on how I decide to divvy it up. So let's do the computation for secant. Let's try to compute the secant of pi over 2 minus theta. So, oh yeah, maybe I'll do this. How many people just already have a guess for what the answer might be at the end of the day? What guess do you have?
It just equals cosecant.
Maybe it's cosecant. And let's go ahead and check that by running the algorithm that we know to run. What is secant in terms of sine and cosine?
1 over cosine.
1 over cosine. So this should be the same thing as 1 over the cosine of pi over 2 minus theta. But what is the cosine of pi over 2 minus theta? sine of theta. Well, so this will become 1 over the sine of theta. And what is 1 over the sine of theta?
Cosecant.
Cosecant. So secant of pi over 2 minus theta is the same thing as cosecant theta. What do you think should happen to cosecant theta? Oh, no, what do you think cosecant of pi over 2 minus theta should be the same as?
Secant.
Secant seems reasonable. And now let's check tangent and cotangent. And I want to have you guys do it. So let's see. Tangent? Cotangent? Take a couple minutes and work those out. Cool. So let's see what people think. What is tangent of pi over 2 minus theta the same as?
Cotangent.
Cotangent? What's cotangent the same as? Anyone want to see a talk through it? Okay, it's the same argument as it's happened a few times. Nice. And I think I'm going to forego the application. Well, I mean, how many people want to see? No, I think I'm going to skip these. We can come back to it if people want at the end. So there's one last identity to try to figure out. Let's try to figure out what happens when you take pi over 2 and add an angle theta to it. And maybe it's helpful to even draw a picture. So there's some angle theta. And now let's also draw pi over 2 plus theta. What's an angle of pi over 2 the same as?
90-degree angle.
It's a 90-degree angle, a right angle. So to get pi over 2 plus theta, we can go pi over 2 plus theta. As a consequence, this little angle right here
Is theta.
is also theta. So that means that this picture and that picture, they look really closely related. So we should be able to think about some sort of geometry to figure out what the new angle, what this new point is. And maybe I'll even draw a triangle. Those two triangles, are they like the exact same triangle?
Yeah.
Yeah, congruent. They're congruent triangles. So all the side lengths are the same, and all of the angles are the same. But this xy coordinate is just like 2 of those side lengths. This xy coordinate is just like 2 of those side lengths. So we should be able to just geometry this question to get an answer. And let's actually do it on here because I'm supposed to be recording this. So here are the 2 triangles which I claim are congruent. One of them has this corner on that triangle given by cosine theta sine theta. This one has corner given by cosine of pi over 2 plus theta comma sine of pi over 2 plus theta. And let's try to think about it this way. Let's think about the y-coordinate first. There's the y-coordinate. Which edge of that right triangle is that y-coordinate given by? The uppy-downy one or the side-to-side one? sorry, no, the vertical or horizontal direction. It's the vertical direction. Y-coordinate is the vertical direction. So that means this vertical length is exactly the sine of pi over 2 plus theta. But now let's go back to the original triangle. That red length, which length is it the same as in the original triangle?
Cosine.
The cosine, the horizontal one. So that red length is the same as this red length, but look at it, it's cosine of theta. So that means the sine of pi over 2 plus theta is the same thing as the cosine of theta. We should be able to do something pretty similar to get cosine, right? So let's look at that cosine of pi over 2 plus theta. Which edge of that triangle gives you cosine of pi over 2 plus theta? The horizontal one. But it's negative. So this blue side length, generally one measures lengths and gets a positive number. So this length is negative cosine pi over 2 plus theta. Which makes sense, right? That's a point in quadrant 2. The x-coordinate will be negative. But this blue length should be the same as this blue length, which is sine of theta. So that means sine of theta is the blue length, is that blue length, is the cosine of pi over 2 plus theta. So you wind up with sine of theta isn't the cosine of pi over 2 plus theta. It's negative the cosine of pi over 2 plus theta. How do people feel? Does that make some sense?
Negative sine of theta.
Yeah, it's getting myself confused, right? The formula I want doesn't have the sign there, it has the negative sign there. How do people feel about that? That seem okay? So, cosine of pi over 2 plus theta is exactly negative sine theta. Sine of pi over 2 plus theta is exactly cosine theta. And let's try to do, because I'm going to ask you to do something similar on the next page as, well, in fact, some of the homework associated with these notes. Let's try to get the same result algebraically. So instead of trying to do some new geometry, let's try to think about all of the formulas that we have previously and see if we can realize pi over 2 plus theta in terms of that. Well, let's try to do it. So I guess first things first, I know what happens if I do pi over 2 minus an angle. Right, I understand really well what happens when you do that. But what is addition of an angle other than subtraction of negative that angle? So here's a fact. Cosine of pi over 2 plus theta, that's the same thing as the cosine of pi over 2 minus theta. But remind me, what's the cosine of pi over 2 minus a thing? By looking at the front page of the notes?
Sine of something minus, just like sine of theta.
Yeah, except it's not theta right now. It's box. And of course, the reason I put a box there is because I want to say, well, what goes in the box to give me an answer right here? I guess minus theta could go in that box. So the cosine of pi over 2 minus theta, well, that's exactly the same thing as the sine of minus theta. How do people feel about that? But now it's like, Easy. What's the sine of minus theta the same as? Possibly by looking back at that front page of the notes.
Negative sine of theta.
Negative sine theta. So, I don't need that. Cosine of pi over 2 plus theta is exactly the same thing as minus the sine of theta. Is that the same thing as we got by doing geometry? Yeah, so that's good. And maybe just for completeness sake, let's do the algebra to do the same thing for the sine of pi over 2 plus theta. And so here's the game we'll play again. The sine of pi over 2 plus theta. Well, certainly adding theta is the same as subtracting negative theta. And whenever you see a step like that, there are two questions you should ask. Can you do it, and should you do it? Are these two things actually equal to each other? So that's, can you do it? Those two things are actually equal. And then secondly, should you do it? The reason I did this is I already have an identity that tells me what happens when I do pi over 2 minus 9. So I'll put like a box around that. What's the sine of pi over 2 minus box?
Cosine of theta.
Yeah, except you don't mean theta there.
Box.
Cosine of box. And in this case, what goes in that box?
Negative theta.
Negative theta. And what's the cosine of negative theta?
Negative cosine.
Careful.
Or cosine of theta.
Yeah. Nice. So, and I guess we should check again, is that the same as the geometry gave us? So that's a nice sanity check when you can do something algebraically and geometrically and get the same answer. That's good. And let's see, in order to give you guys some time to walk on the stuff on the next page, I think I'll just go ahead, well, yeah. No, I'll talk through one of them and then I'll write down all of the other ones. I don't know, I think I did, I'll do secant this time. Let's try to compute the secant of pi over 2 plus theta. And you know exactly what I'm going to do, right? Step one, what is secant in terms of sine and cosine? It's 1 over cosine. So let's do that first. So this will give me 1 over the cosine, and I'm not going to do anything with the angle yet, pi over 2 plus theta. So step one, translate to cosine. What's cosine of pi over 2 plus theta? So this will be the same thing as 1 over negative sine theta. And I don't know, negative number shouldn't be in the denominator, they should be in the numerator. So move it to the numerator. So you see negative 1 over sine theta.
Which is negative cosine.
Which is the same as negative cosecant theta. So secant of pi over 2 minus theta is the same thing as negative cosecant theta. Cosecant will be the same thing as secant theta. Tangent will be the same thing as negative cotangent theta. Cotangent will be the same thing as negative tangent theta. And maybe we'll check these ones really quickly. And let's do it by looking at the board. What's the angle between these two lines?
Like
That angle. So if this is an angle of theta got you to there, an angle of pi over 2 plus theta got you to there, how much further after theta do you have to go to get to pi over 2 plus theta? Pi over 2, right? Because theta plus pi over 2 is the same thing as pi over 2 plus theta. That's a right angle. These two lines are perpendicular. How do slopes of perpendicular lines compare?
opposite inverses.
They should be, yeah, potato, potato. They should be negative the reciprocal of each other. You're both right. So the slope here should be exactly the negative reciprocal of the slope there. So this slope should be negative the reciprocal of tangent of theta. There's negative the reciprocal of tangent of theta. Okay, so the geometry continues to agree with the algebra. That's nice. People feel pretty happy? So here is the game that I want you guys to play now. So I'm going to tell you a single value for a single trig function and what quadrant that trig function lives in. You are going to tell me sine and cosine at all of these angles. So suppose you have some angle alpha, which lies in quadrant 1, which satisfies that cosine is 3/5. Compute sine of alpha, cosine of pi over 2 minus alpha, all these other ones. Where most of these will just be look at the identity on the front page. And I'll give you a few minutes and then I'll say a few words there. And I really want you guys to like collaborate with each other. I want to use this. Let's see, I think I want to use the last couple minutes to give hints if desired. So maybe let's even just start with this. Did everyone successfully figure out what the sine of alpha is? Does anyone want me to talk about how to find the sine of alpha? Okay, cool. So those of you who did successfully find the sine of alpha, what's the most important trig identity? Sine squared plus cosine squared equals 1? Yeah. Sorry, yeah, you raised your hands, but I wanted people to just be very rude and shout. So if you want to find the sine of alpha, use this fact. For any angle alpha, the sine squared of alpha plus the cosine squared of alpha is always equal to 1. So, you would like to know what sine is. I'll just rename it as s. S squared plus, what's the cosine of alpha right now? 3/5, I think. So you get s squared plus 3/5 quantity squared equals 1. Does that look like you could solve that for us? At the end, you'll get like a plus or minus issue. Is this sine positive or negative? I call it a negative. Do I hear a positive? What quadrant does this thing live in? Quadrant 1. In the first quadrant, is sine positive or negative? Positive. So it'll be whatever the positive choice is. So the second thing that I'll say in the remaining minute and a half I have is let's talk about the ideas you need to generate 10 through 13. So let's try to compute cosine of 3 pi over 2 minus alpha. And so the first observation I'll make is that's the same thing as the cosine of pi plus pi over 2 minus alpha. Right, that's just manifestly true, right? Pi plus pi over 2 is 3 pi over 2. But what happens when you do pi plus to an angle? What does that do to cosine?
It's just negative cosine.
Makes it negative. So just like before, I'll put this in a box. So this should be exactly the same thing as negative the cosine of pi over 2 minus alpha, because this was the thing in the box. But what's the cosine of pi over 2 minus alpha? I think it's sine. I didn't look to the front page to be positive, but I think that's sine of alpha. But I guess we didn't finish computing what the sine of alpha is. But assuming you actually get problem 1 done, you know what the sine of alpha is. Yeah. Oh yeah, I lost the negative sign, didn't I? What a chump. This negative sign needs to persist. So it'll be negative whatever the answer to number 1 is. Thank you for saving me. So what do people think? People think they can reasonably do this in like maybe 10, 15 minutes? Well, maybe a little bit more. It's not like so long time.